Alrighty, pre-calculus. It's time for Friday morning pre-calc. Good morning, A3 Precalculus CP. Today's Friday, May 8th. Hopefully you're having a great day so far, and hopefully it will get even better now that we're going to talk about some sum and difference identities this morning. What else? What better is there to do on a Friday morning than talk about sum and difference identities? I can't think of anything. Maybe to talk about solving trig equations, but we're not there yet. Adam, you made it just on time for some sum and difference identity stuff. So I'm happy that you stopped on by. And Ashlyn, too. All right, now the gang's all here. Just about. We might be missing one more, but I think the gang's just about all here. One thing that I want to make sure I remind you of is, or actually two things. Number one, make sure you fill out the attendance form on Google Classroom. It's the same one every day. It's important that you do fill it out because you need to have a record that you're here for attendance. Second thing is everybody's been very good about muting their microphones and webcams and stuff. I do want to always encourage that if you have a question, please speak up or type it in the chat. Do not be shy. Do not be afraid to get a question wrong or anything like that. We all make mistakes. It's totally fine. Just participate, ask. I'm here to help you, so I want to help you as best I can. Last but most certainly not least, there will be another progress assessment sent to you today, just like every week. It's our weekly routine. The reason why I really want to get that out to you today, you might be like, oh, geez, do we really have to have one every week? First of all, I think that's more than manageable. But second of all, yes, because unless you want to have some work to do, like during the weeks of preparing for a graduation and stuff like that, which I certainly don't want to. So, I don't want to put you through that. So that's why we do need to be maintaining our weekly schedule. Now, the fact that we do have class Friday this week instead of Thursday, which is normally the case, means that I am going to give you one extra day to get that progress assessment to me. So that progress assessment will be sent to you via email. I'll make sure to send it out during lunch. And it will be due to me on 11:59 p.m. on Monday night. Okay, so as opposed to the usual Sunday deadline, just extending that one day to Monday night. All right, it will be on all of this sum and difference identity stuff. And what I would like to do today is I'd like to go through a bunch of problems on sum and difference identities. So hopefully you can get a good sampling of what's going on. All right, we've had both Maddies jump in the meantime. Excellent. I think everybody, we're all good to go, right? So, any questions before we get started? Or are we ready to jump right in? Well, let's jump right in then. So, starting with a little bit of a recap from last class, and then I'm going to go into some proofs today on sum and difference identities. That's sort of going to be what we're going to do. So the first 10 minutes or so are going to probably be a little recap of what we did before, just to make sure I reinforce those concepts with you, because it was a lot of information thrown at you last class. And then the next 20 minutes or so will be about a little going into proofs using these sum and difference identities. The proofs really aren't really much, they're really not much different than what we've done before. It's just now you have an end goal. Just like before when we saw the simplifying problems, it's just now throwing in these sum and difference identities into the mix. All right, so this is what we looked at last class. We had, if you're doing the sign of any two things added or subtracted together, it is equal to the cosine of the first, or sorry, the sine of the first times the cosine of the second, plus or minus to match the sine of whatever this is, the cosine of the first times the sine of the second. All right, so make sure that you know this formula. The other one that you need is the cosine sum and difference formula. If you're doing the cosine of any two things added or subtracted together, that's the same as the cosine of the first times the cosine of the second, minus plus. The reason it's written as that way is because the sign flips with cosine. If you have a plus here, you're going to have a minus here, and if you have a minus here, you have a plus here. Sine of the first, sine of the second. Okay. The reason why this is helpful is this allows us to find the exact value of something like this, the sine of 15 degrees. 15 degrees is not on our unit circle. Well, it is, but it's not one of our nice angles on the unit circle. It's not 30, 60, 45, 90. It's not one of the nice pretty ones. It's one of those in between. But what we can do is we can recognize that, 15 degrees is really the same as saying it's the sine of 60 degrees minus 45 degrees. Right? Isn't that true? That the sine of 15 degrees is the same as 60 minus 45, because 60 minus 45 is 15. Given that, we can then use our sum and difference identity to actually find a value for it. And I could say, well, that's the same as the sine of 60 minus 45 is the same as the sine of 60, sine of the first, cosine of 45, minus, because I see a minus in here and the sign stays the same, minus the cosine of 60 times the sine of 45. Just like that. Everybody sees that, hopefully? Now, using your unit circle, and again, what I advised last class, I'll advise you again, make sure you have your unit circle handy and your unit circle exact value chart handy. I did post it on Classroom, so make sure you have that with you. The sine of 60, well, the sine of 60 is rad 3 over 2. Times the cosine of 45, rad 2 over 2. Minus the cosine of 60 is 1/2. Times the sine of 45, rad 2 over 2. And you can get that the sine of 15 degrees can be expressed as this is going to be square root of 6 over 4 minus square root of 2 over 4. And since those have a common denominator, you can stick them together to get the expression of the square root of 6 minus the square root of 2 all over 4. Okay? And that's how you can express the sine of 15 degrees. Does that make sense to everybody? It's just using the formula. All right? We also saw that we could take the formula itself and actually go in reverse. We could say, well, what if I wanted to simplify this expression? Sine 65 cosine 25 plus cosine of 65 times sine of 25. Well, if I have that expression and I want to simplify that as much as possible, do you not recognize that this is really the same as this? Yes? So we can apply our identity in reverse, and we could say, well, that's really the same as the sine, because that matches the sine formula, the sine of A plus B, 65 degrees plus 25 degrees. Well, what's 65 plus 25? That just becomes the sine of 90 degrees. And what's the sine of 90 degrees? Sine of 90 degrees is 1. So that whole big expression is just equal to 1. Okay, and you could actually plug that into a calculator and find also that it's equal to 1. But using your sum identities, that's how you can actually rewrite and simplify. Otherwise, think of how you'd have to calculate that. It would be a mess. You wouldn't want to deal with that. Ain't nobody got time for that, as they say, as the kids say. Another thing that we could do is we could actually simplify expressions using these sum and difference identities by expanding things out. So I could have some, yeah, no cap. I could have sine of pi plus x plus the sine of pi minus x. Thank you, Aiden, for that. And we could try to simplify that expression as much as possible. We could do that by using, again, our sine sum and difference identity up at the top. And I could say, oh, the sine of pi plus x, a plus b, is the same as, just simplify this guy. That's going to be sine of a, so sine of pi, cosine of x, plus cosine of a, so that's cosine of pi, sine of x. Plus, well, we could also simplify this piece now. And I can say that it's going to simplify to, again, using the sine formula, sine a, sine of pi, cosine of b, cosine of x, minus, because the sine stays the same, cosine of a, cosine pi, sine of x. Okay. We notice that when we do that, you can see that cosine pi sine of x, negative cosine pi sine of x is going to go away, right? This and this are just going to cancel out. I now have, let's see, sine of pi cosine x and sine of pi cosine x makes 2 sine of pi cosine of x, right? Because I have one of them and I have another one of them, so altogether I have 2 of them. What's the sine of pi? Well, the sine of pi is 0, right? Isn't the sine of pi just 0? So this would really be 2 times 0 times the cosine of x, which would be 0, right? And so therefore you could say that that whole expression is just 0, right? And what you're going to see starting in about 30 seconds is you're going to see a problem that says prove that sine of pi plus x plus sine of pi minus x equals 0. And so that's exactly what we're going to go into now. And so that would be the proof of that. So that's really what we talked about last class. Does anybody have a question on any of that stuff? we feeling all A-OK and hunky-dory? All right, fantastic. I take your silence as, Mr. Giorgio, this is crystal clear. Everything you do is fantastic. I appreciate that. So, in any case, let's go ahead and take a look now at some proofs involving this stuff. Again, is it really that different? Not really. It more just gives us a goal to work towards and asks us to use these sum and difference identities. All right. Let's do one first involving, we'll do a couple involving sine. I haven't done any involving cosine yet. The last problem I have does a cosine one, so we'll do that as well. But let's start with a problem like this. Ready? I like this problem a lot. Let's prove that the sine of a plus b plus the sine of a minus b, all divided by the cosine of a times the cosine of b, prove that that equals 2 times the tangent of a. Okay. Again, is this scary and different than what we've done before? Well, it's certainly a little more involved, but it's really all the same concepts. We now just have an end goal to work towards. So we're obviously going to work with the left-hand side. That's by far the more complicated side here. So on the left, I could say, well, sine of a plus b, that's going to be sine of a cosine b plus cosine a sine b. I now have plus sine a minus b. So plus sine of a minus b is going to be sine a cosine b minus cosine a sine b. Right? And that's all going to be over cosine a cosine b. Notice, by the way, that I could not combine the denominator to make that cosine squared, even though you have two cosines. They are of different things. I think that's obvious, but just want to point that out just in case. If this was cosine A, absolutely you could say that's cosine squared of A, but it's just cosine A, cosine B, they're different things. Like if you had X and Y. So in any case, let's see what we can do on the top. There's a lot of simplifying we do. Cosine A sine B, negative cosine A sine B, that's what we saw in the previous problem. That cancels out. I now have sine A cosine B, another sine A cosine B, so it makes 2 sine A cosine B, which is good, by the way, because you see the 2 in the goal here, and you're like, ooh, this is good. We're on the right track. All over cosine A cosine B. Now, hopefully you notice, ooh, wait a minute. Cosine B over cosine B is going to go away. I'm left now with 2 sine of A over cosine of A. And how can you rewrite sine over cosine? Well, using our our quotient identity. I forgot to actually add the sum and difference to this little cheat sheet on my sidebar here. I'll make sure I do that. But using our reciprocal, so I keep saying reciprocal, using our quotient identity, we can say that this is the same as 2 times the tangent of A, which is now equal to the right-hand side. And so my proof is complete. Does that make sense to everybody how that's done? Don't forget the proof signature, right? Mine's Triforce, but you can do whatever you want. Okay, very good. Let's go into, I got 2 more for you, and then pretty much done for the day. All right, so let's do another one. Maybe be done a couple of minutes early today. Let's see, we got prove that the sine of x plus y times the secant of x, secant of y, is equal to the tangent of x plus tangent of y. Okay, so we're going to try and prove that guy. Well, the first thing I would probably do is I'd probably just expand. Well, obviously, again, work with the left-hand side. More stuff to do over there. Let's expand that sine of x plus y. Using our sum and difference formula, we can say that this is sine of x cosine y plus sine y. Oh, sorry. Plus cosine x sine y. Right? So it's our little sum and difference. And now we're going to multiply that by secant sine. Oh, is that secant sine? Or secant, sorry, I wrote it incorrectly. My fault. This is times secant of x times secant of y. Sorry about that. I wrote it incorrectly. That is my fault. I'm glad I caught it now, though. I was like, wait a minute, this doesn't look like it's going to match up. So, again, just to make sure there's no confusion, The problem was sine of x plus y times secant of x, secant of y, not sine. I mistakenly wrote it as sine. My apologies. And we'd say we want to prove that that's equal to tangent of x plus tangent of y. We would work with the left-hand side, and I'd say, well, using our sum identity here, we can expand that to be sine of x cosine of y plus cosine of x sine of y. And I have my secant x, secant y that I didn't touch yet. Okay, sorry, I wrote that incorrectly. What I can do now is I can distribute this and this to here and here, right? It's just like if you had any term here, you could multiply it by this, multiply it by this. You would get the following, which looks intimidating, but is absolutely not. You would get sine x cosine y, now times secant x, secant y. Plus, really the same thing here, or a similar thing, cosine x sine y times secant x, secant y. Does that make sense to everybody how that's done so far? Again, looks scary, but look at what's going to happen, unless anybody has a question. But look at what's going to happen. We could say secant of x cosine of y and secant of y. Well, secant is really just 1 over cosine, right? So let's rewrite this here. We have sine x cosine of y times 1 over cosine of x and 1 over cosine of y. Notice cosine of y and 1 over cosine of y would just go away. And so we'd be left with here of sine x divided by cosine x. We'll get back to that in a minute. The second term, notice, very similar. I have cosine x sine of y. Secant of x is 1 over cosine. Secant of y, 1 over cosine of y. Notice cosine x, 1 over cosine x goes away. I'm left with plus sine y over cosine y. And how, of course, do you express sine divided by cosine? That's your tangent, and that's going to lead exactly to the goal we're looking for. That's tangent of x plus tangent of y, and that's exactly the right-hand side. So we're done. Okay. Does everybody understand how a proof like that was done? Everybody's A-okay? All right, one more. One more. Ready? All right, let's do prove. Last one. That cosine of pi minus theta plus sine of pi over 2 plus theta is equal to 0. All right, that's the last one we want to do. Just to give you a little reminder on our cosine identity, remember that the cosine of a plus or minus b is cosine a cosine b minus plus, opposite sign, sine a sine b. And we also need the sine one here as well. Sine of a plus or minus b is sine a cosine b plus or minus cosine a sine b. Okay, just to throw those little reminders in the bottom corner for you. So let's take a look at how we'd have to expand this out. Again, obviously working with the left-hand side, there's no reason to delve into the right and try to take 0. I don't even know how you would take that and get to the left. I mean, I'm sure there's a way, but definitely more illuminating to work with the left-hand side. Let's expand out both of these things. Using the cosine sum and difference formula right down here at the bottom of the screen, we'd see that this is cosine of pi minus theta. We got cosine pi, cosine theta, plus, because remember, when you're doing cosine, the sign switches around, right? Cosine uses its cosine. I'm going to keep saying that. We got sine pi, sine theta. So that's how we expand this. That goes to that. This now, watch how we're going to expand this. It's going to be using the sine formula. Sine pi over 2 cosine theta plus, because the sign in the sine sum formula stays the same, cosine of pi over 2 sine of theta. Ooh, fit it right at the end of the page. It's getting a little worried. All right, how is this all going to combine? Let's see. We get cosine of pi, cosine theta, sine of pi, sine of theta, sine of pi over 2, cosine theta, cosine pi over 2, sine theta. Well, let's figure out what the actual values are. The cosine of pi, we know on the unit circle. The cosine of pi is 180 degrees. What's the cosine of that? Well, that's -1. So I have -1 cosine of theta plus. The sine of pi, well, pi, again, 180 degrees. What's the sine of 180 degrees? That's 0. 0 times sine of theta, so obviously that's going to go away. Here I now have sine of pi over 2 cosine of theta. Well, what's the sine of pi over 2? Pi over 2, 90 degrees. Sine of 90 degrees is 1 cosine theta. Maybe you kind of start to see it coming together now. And then plus cosine pi over 2 sine of theta. Cosine of pi over 2, that's 90 degrees. That's 0 times sine of theta. It's obviously going to also go away. So now, look at it all coming together. We got -1 times cosine of theta plus regular old cosine of theta. That obviously is going to cancel out and give us 0, the same as the right-hand side, and we are done. Okay. So notice, sorry, the paper kind of shifted around and all that through my excitement. But notice that it's really not much different than what we've done before. It's now just taking that and trying to reach a goal. That's really what the distinction is between the proofs and just the regular old problems. Does that make sense to everybody? Does anybody have any questions, comments, or concerns on the examples we did today? I will do a little brief recap, but does anybody have any questions, comments, or concerns about that?
I have a question on the last one.
What's up?
So when you do the cosine pi minus theta, I'm just confused on how it breaks down. Like, I get the cosine pi and cosine theta, but where does, like, the sine pi and sine theta
That's a
come
great
from?
question, Molly. Thank you for asking. That comes from the cosine sum and difference formula right down here. Do you see that the cosine sum and difference is defined as the cosine of A plus or minus B breaks down to be the cosine of A times the cosine of B minus plus, meaning the sign switches, sine of A, sine of B. So that's just following the formula. It's just saying we have pi minus theta. So pi is A, theta is B, and I switch the sign in the middle. Does that make sense? It's just breaking down using the formula.
Okay, yeah, that makes more sense.
Okay, cool. And the sine thing is the same thing too over here. We just break down using the formula.
Thank you.
Oh, you're welcome. Any other questions about that? Okay, so just a little recap on what we did today. What we did today is just, again, revisited our sum and difference identities. Very important that you know these. Again, I'm going to add them to my little sidebar here. I forgot to do that, so I will make sure that I do that. Sine of A plus or minus B is the same as sine of A cosine of B plus or minus cosine A sine B. Notice the sign stays the same. Cosine of A plus or minus B is cosine A cosine B minus plus, the sign switches, sine A sine B. Okay? We can explore that in a variety of ways. We could see problems where we could find the exact value of a certain angle, like the sine of 15 degrees. 15 degrees is not normally a nice unit circle value, but I can rewrite 15 as 60 minus 45. The reason I specifically chose 60 and 45 is those are two nice unit circle values, and so that breaks down nicely. I could also go the other way. If I have something that's expanded out like this, you could just recognize that, ooh, that matches up with this, and we could just rewrite it that way. And lastly, we could see problems that we just have to simplify and combine like terms. Something like this. We can expand out this sign, pi plus x, expand out this sign, pi minus x, and we get 0 in the very, very end there. Okay? We saw today also how that transitions into proofs. Again, very similar to the identities proofs we've done before. But now what you're doing is you're just saying, I can just incorporate the sum and difference ideas. I can say sine of A plus B expands to this. Sine of A minus B expands to this. And then we just go through our steps. Cancel the terms. I cancel again. And sine over cosine by our quotient identity comes out to be tangent. So that's how you get to tangent. This one here involved a little breakdown, a little distributing. And then once we did that, we switched everything to sine and cosine and found that it was tangent x plus tangent y. And last but most certainly not least, We saw a little cosine and sine intermingling there, sticking together. Cosine breaks down like this, following the formula of cosine. Sine breaks down like this, following the formula of sine. And then we just combine all the like terms. Any other questions or concerns? Okay, let me just remind you quickly that there will be a progress assessment sent your way via email, just like the previous ones. It is going to be due Monday, 11:59 p.m. Again, the reason for the one-day extension is the fact that we have class Friday instead of Thursday, so it's the same amount of time, just shifted by one day. Next week, we're going to look at even more identities, not sum of difference. We're going to look at double angle formulas, so it's going to be a good time. Or if you're doing the cosine of 2 theta instead of the cosine of theta, how does that change? We're going to find out very soon. Other than that, thank you so much for your attention and focus today, ending just a couple minutes early. We've gone a couple minutes over before, so here's your little break, a couple minutes early. I hope you have a fantastic weekend. I hope you have a great Mother's Day. Happy Mother's Day to all the moms out there, and enjoy, all right? Other than that, that's all I got for you. Have a great rest of your day, and thank you for your attention, respect, and focus today. Bye, everyone.
Later, Miss Giorgio.
Later.
Have a nice weekend.
You as well.